And thank you for the invitation to present, I wouldn't call it a paper. I more call it a 20-minute experience of exploration. When I got that invitation to present something of a practice which is almost 5 decades and plus, and after I got down from the Chennai airport in its total chaos, my memory of partly designing the Gemini flyover and many of the things in the 1970s came into my head. When we did some composite structures, like one of the earlier speakers had said, that we were not allowed to use steel. We were into housing, we were into all sorts of things, including the Fisherman's Cove and large-scale, what you call multi-storied, large-span structures. Around the same time, I had the fascinating meeting with Buckminster Fuller a little earlier, who introduced me to the geodesics and the tetrahedra, which made me design the Bube in Delhi, which won the National Award in 1972, plus the Cochin Stadium Awards the next year for the biggest hyperbolic parabolite ever built, plus the Tirupati Auditorium. Then I said, no, I'm entering into too many of the large projects. Let me get down to what really matters. We went into homes again in the, what I would call the early part of 1970s, and I went abroad for exploration of various factors. Then I was totally disappointed the way the West handles either material, technology, or architecture. Gave them 4 years. They said, no, flight to Canada, flight to US, flight to anywhere you want. I said, no, India calls. So did my little daughter, who coordinates all these works. I came here. Then I deliberately, when this thing came, we had done some very large span structures in steel and tubular steel structures. Then what are the biggest factor that affected India is the homes. At that time, we were not allowed to use a lot of steel. Towkari, tar steel, everything. Within less than 1 ton is 1,000 square feet of steel is what we were looking at. Then something happened. I found to study nature a lot. I'll go back to you on various things. These pictures are there as a background of steel buildings that we have done. But my talk will somehow connect and disconnect with this. I believe that connection and disconnection is the most important factor of architectural experience to explore. This became a factor, that's why I use the word steels. Steels. Till now, concrete and brick was taking over the construction of homes. Recently, I found, working on many aspects, that steel has a phenomenal aspect and a discovery not many people have done to explore into the factor of housing. One of the first experiments we did purely as what I would call an architectural wonder, many engineers would disagree, was when I saw a building house climbing up with steel windows and steel doors. I asked that contractor, don't build the walls. Put the windows, put the doors, put the slab. He thought I was mad. I found that steel in the window and the door was much stronger than the built walls. Now I had freedom to do what I want with the walls. So instead of doing the other way, we did the skeleton. Then observing nature again in a different way, you start looking at one aspect as the insect, the ant. Then you start looking at something like the frog. Then you start looking at the human flesh. You find either the bone is outside and the flesh inside, or the flesh outside and the bone inside, and then the skin. These are the 3 factors that come into an architectural, or what I would call an adventure. So I said, if I shift the steel out, what happens? But in 1970s, 80s, I didn't have access to good steel structures at all. The only steel material I could get was borewell pipes. So if you notice some of my earliest buildings, all designed with borewell pipes. 4-inch borewell pipes, 6-inch borewell pipes. I would even get the borewell fellow and say, give me 5 borewells. After it goes about 10 feet, I'll say, stop. He'll say, water. I said, no, I'm not interested in the water. Put 10, 10, 10 feet. Then I found I could put my little buildings on top with these bore wells. And bore wells were being subsidized, so steel was very cheap for that. Not for other reasons. Then they shifted to plastic bore wells, so I had to get away from them. By the time steel had progressed and people had understood the importance of steel, that it is not a material. That's why I was talking to somebody and said, the few things that happened was, what is the embodied energy in steel, which is the cost factor. The production cost, it's very heavily taxed even now, which is where the problem comes. Then I started looking at many adventures of steel factors of using, if you notice, around up to 80s, we never got the tubular sections other than the bore well pipes. We had to take the L section or the T section and bend it and to make it into tubular, which is very heavy. So I used to take sheets of plates and bend them around. In fact, when we did some of the projects, we were almost sued for having bent a flat sheet into a corrugated sheet and pouring concrete on top and saying it will stand. Today, I find it is a practice. People were talking about Chinese technology. No, sir. We are 40 years ahead of the Chinese as far as your tubular steel goes, as far as the hollow concrete panel goes. We did it right here opposite on the other side of the river. When the British Council built a thing there, we used the panels. We did it for something for housing again. When VGP at that point said, can you do housing with steel and hollow concrete slabs, which was a very brave thing. But unfortunately, I wasn't very happy, so I ventured out and said, let me see what happens, and then came back to my hometown and left the practice here for somebody else and took over Bangalore, which went for various factors of discovery of various things. Now, what happened was, I'm limiting myself to the engineering or the technology and art engineering of the steel structures. What is the fascination about steel is time and space. I can do it faster. I can create greater spaces of freedom. And I can pre-engineer it if I want. I can pre-architecture it if I want. But as somebody also was saying, but architects love to modify and change. I love to modify and change. Even when I go to a site, that's why we don't take on very large projects anymore, because they don't allow me to change and modify. As I walk in, I grow, my mind grows. I go to the site and, shift it, move it. And I find that is life. I don't want something that is preconceived to be built. That is wrong. I mean, that is my architectural language, and I abide by it, and I continue to go by it. Then the factors that happened was the question of material came up. I was discussing again a lot of things. After concrete, what happens? Is it timber? Is it iron? Is it steel? Or is it composites? I'm glad the IIT professor was here, because in 1970s, again, we had a very large meeting in IIT when we were talking about composites. I believe the future is in the composites. But steel has to play a large part, because when we were discussing there, we were not looking at steel as a long items of elements. We were looking at hairs of steel, which could give us composites with concrete to give us reinforced, what we call polystraw grains, concrete composites we used to find. And I found if I magnetically treated, I could get greater structures. Here, the Russians helped me a lot to understand how I could make each grain go to the same direction. But now I'm after a question, which I did ask somebody in the lunch interval. Can I get steel which does not have magnetic properties? You're asking me why. I'll touch it as I go on, because I believe it's very important to understand it. The other thing that happened to get me on when the structures came is the cobweb. It's the strongest of things if you understand scale and cobwebs. I find steel allows me to design a cobweb, which means my steel columns don't have to be directly there. It can just go like the nerves all over, run the spine up, and give me structures that go beyond imagination. But to give it form or give it a perspective in the beginning is very, very difficult. You can only organically grow. But you have the concept of why you're using that space, why you want that space. This became a fascinating adventure. This came to. Then the factor of home again hit me and said, India needs homes. And I believe small is beautiful. How do I do this? We did one called the hexagon growth factors, which we again presented here a couple of years back when the previous chief minister was here. He accepted it for the tsunami housing. But unfortunately, before we could get everything going, he was no longer chief minister. Anyway, that's a long story of Tamil Nadu, Karnataka, me going up and down. Then we went to some housing in Andhra Pradesh where the then chief minister, who is now the present chief minister, made me do a lot of explorations of how to do housing. I said, let's again combine with steel. He said, I leave it to you. We did a few experiments. We worked on it. I said, now I leave it to you to do it because it's much more fascinating to work with. The factor that came up was the foundations, the basements, to go below. How do I shield it? How do I waterproof it? Steel has still not given me the full answers. I still find it when it probes below the earth, it still wonders and wonders and tells me, what do I do? How do I seal myself around? Concrete doesn't. Concrete leaks and weeps, but it still holds. Whereas steel hasn't given me the answer. We are looking at something around there and say, can I work with composites on such factors? Because I have in one of my factors a very fascinating thing that the future of the world is underground or in space, not on the surface. We will be building homes in the moon or in space or underground. Underground will be ecothermal, absolutely fascinating way to build. In space, there's no limitation. And I believe in the next 15, 20 years, that's where the exploration is. That's where the future of the youngsters should go. That's why we are promoting something like 500 schools of architecture, hoping that there'll be 5 students from this 500 schools who will come and explore in a thesis and practice something out there. Imagine 20 years from now, what did we have 20 years before? Nothing. Something is going to happen. We must be prepared for this. Then the other fellows who really ate me very much on this is the timber fellows. They grow timber a lot and grow what is called construction timber. It has its laminar problems, structural problems, but it has one quality which defeats steel, which is why I was asking somebody, what happens during fire? How do I not transmit the heat from that tent to this end on steel? Can I stand here when there is a fire there? On timber I can. On steel I can't. Can I get a steel that will not transmit that steel? The conductive process or convection process or whatever is the process that the chemical engineer, the physics use, can it be done? I believe it can be. Then they also said there is some coating that comes that can prevent fire from literally what I would call collapsing the steel. If that comes, I feel the future is going to be brief. I believe in that. One of the other reasons why I took to steel is it is very light. Now, I told you about the foundation problems of structures, that if I go deep, then we worked on an experimental structure. I don't know whether they're showing the plans here because I leave it to my girls and boys in the office to just give me some 20-minute run. If I build a ball in steel, a geodesic dome, total, double dome, if I float it on the surface, it doesn't need a foundation. All I have to make sure is the floor inside continues to stay horizontal, and I can move the ball anywhere around. I can move it on the sea sands, I can move it, if I can float it, I can move it on the river. So what happens? I get a home. This came not to the shock, but because of the floods. We saw a lot of buses floating in the floods. If buses can float on the floods, why can't homes float? That's a negative thought. This could be a positive thought. If I could make domes, which are very structural, the geodesic dome double, works well. If I do a fiberglass lining or some other lining at the bottom and then allow it to run, what happens? Then we conquer the seas, we conquer the rivers, we conquer many other aspects which are normally not thinkable. This is another aspect that gave housing a large factor. Another factor that also grew along with this thought was if you put one ball over another ball over another ball in a very, what I would call the sequential manner of understanding structure. This I learned from an Israeli architect. He said you don't have to redesign the structure at all. You use one element and keep multiplying it. It could be half hexagon or half dome. You could go gradually up, up, up. You will find the load distributes itself. You can have what are called as walk-up apartments. walk-up units, which are very easy to construct. You don't need many calculations except the beginning, and somebody to supervise the movement of space, so there's convenience of going up and below. Then we came to the other factor, can we have gardens on top? The problem again with steel is, can I make it rust-proof and waterproof? I believe the future is in stainless steel or any other aspects. We are trying one project where we're using stainless steel. We're using it with glass. Initially, we thought the cost was high, but the welding of stainless steel was a different factor. But we found youngsters, even there, I don't believe skills are difficult. Why are we importing anybody from anywhere? My car fellow who repairs my car said, sir, I will do it. Then I found he not only left his car business, started moving into the housing business. Because today's cars don't require so much maintenance. Even the dents are all taken care of by the insurance and things that run away. So he came into the picture, and I found with this fabricator, I could work phenomenal structures. He would even give me broken parts, pieces, and then we would even combine and work something out to say, why can't it work? We called it the reverse composites, or what we call the general composites, to create planes and very interesting spaces, which could be a house. Now, steel is bad at that because it works in 1 mm, 2 mm, even less, maybe you people better at that. How do I stop transmission of heat? This is where I was talking about, can I grow gardens on top of it? Is it possible? Yes. With difficulty, how do I prevent rusting? These are factors that have to be what I could take an advantage of, or take in consideration of, or taken into cognition of. There are factors that work on this. We started doing for aerospace and other people some large structures, for the university some large span structures. We have done some very large span structures of geodesic, almost 220 feet by 1,000 feet and things. But then those things don't excite me. The excitement comes in the small things. Can I get that spaces going? Can I get the minimal tubular thing to work? Can I get tubulars to bend in factors that I can create something that happens? Can the housewife work with the mason and create a home? I find that's the big adventure that's going to happen, where I usually call it waste to wealth. This reminds me of a very large steel factory company which called me and said, we have a lot of steel lying around, what would you do? I said, what do you normally do? We said, we don't know what to do with this. But I find the steel which they throw away costs hardly 1/10 or 1/5. I said, even if I waste more steel on it, you can still better buildings. But then it was not doing justice to the steel, but it was doing justice to the waste, which was, again, a fairly fascinating composite. I learned from IIT here and others that you don't really have to join steel to steel in concrete. You can bypass and do it, you'll still have the same strength. These are factors which I find youngsters should start understanding the quality and the properties of steel. This was 70s, 80s, and 2000s. Then I went to the other factor of the last few ones, which I'll come back as I come back to work with, why I asked you for a non-magnetic steel is, I don't know how many of you believe in the Vastu Shastra principle. They all come with a magnet and say, put it here, put it there. I start looking, this is one of the buildings, which is nearly 700 feet tall, which is why I was looking at, said, can I get non-magnetic steel on this? Then we were looking at this from 1999 onwards, I've been looking at this factor. One of the factors in this is, if I've got the clearance to build it, the only condition is I must use non-magnetic steel. The only factor that I went around is, can I rotate the building? I found the wind forces can rotate the building in the central axis. We found it can rotate the building. You can even rotate the top. That altered the factor of the Vastu thing, and the thing said, southwest is anywhere you want, whenever you want. The sun is with you, you move along with the sun. The rishis and the gurujis who saw me smiled and said, okay, Jaisim, it's up to you, but still we want to hold that magnetic property on your head. Can you do it? I don't know. Maybe the steel people here will be able to help me out and say, how can I make steel non-magnetic? Only thing we have done here is, this is for a university. This is where I was looking at these aspects. We started rotating, but luckily for me, when I presented this paper on this rotating building in Dubai, an young architect came up to me and said, can I have the slides from you? Last year he wrote me saying, "Sir, we have not really got the slides from you 10 years back, we are building it." The rotation. I said, "Great." People said, "Do you want to sue him?" I said, "No, he's got the ability to get it cleared and built. That is an achievement that we can have. Why stop it?" So this is what happens as an architectural adventure. I don't mind somebody saying this can be done and you can't do something, I can do it. I find that is the difference of being different. Without being different, I find to create and achieve is more important than to hold on to something else or something which you possess, and when you die, it dies with you. That should not happen. That is the building out there, shown in 1999 out there, and then pushed back again. The other factors that come with steel is, again, to homes. Can I make the whole university inside? Can I follow the principles of history and heritage in this? Yes. Nobody says it can't be done. Not does heritage. They knew iron. They knew phenomenal things. Why can't we do this in steel and other aspects of steel that can happen with this today? The factor now I look at very strongly is, I think it's time architecture and steel and other factors along with the new materials goes global and makes a presence of integration to all of us in an unbelievable way. I believe the future is this industry can integrate with other industries in the architecture and engineering field. Art will fuse with technology and great space in time. Thank you.